Good afternoon, everybody. My name is Trevor Internosha. I am the design supervisor at the Argen Corporation. And today we're going to go over some basic split file designs to ensure that you have complete accuracy on your split files after manufacturing every time. Argen is a global leader in zirconia manufacturing and the world's largest manufacturer of dental alloys. Our 95,000 square foot manufacturing center located in San Diego, California, houses more than 110 printing and milling machines, where we produce a wide range of high quality digital products. We have offices in the US, Canada, UK, Germany, and distribute in over 100 countries. We've been working hand in hand with 3Shape since 2012, and we are one of the largest resellers of 3Shape equipment in the United States. We work closely with both the US and Denmark 3Shape teams to help test and provide feedback on software releases. Argen IS custom abutments are produced from blanks that are FDA 510K cleared and backed by an extensive warranty. Our custom abutments and screws are certified OEM equivalent and function comparably to OEM parts. Our integrated automation process ensures consistency, quality, and strict tolerances. And we will show you a video on that.
Argen's manufacturing processes and standards are designed to create the highest quality implant solutions. Argen's end-to-end manufacturing allows us to maintain complete control of the abutment manufacturing process, beginning with the production of the abutment blanks. Argen has CNC Swiss screw machines on site that mill titanium blanks to the exact specifications of the intended implant platform. Our blanks and screws are engineered with industry-leading tolerances. Argen certified OEM equivalent abutments are FDA 510K cleared and are manufactured through an ISO verified process. Blanks are rigorously tested using a Nikon optical inspection system that validates the unit's specifications. Argen created custom milling strategies to integrate seamlessly with the manufacturing process for more precise and controlled production. Custom robotic automation allows for increased output and more efficient production. The robots swiftly transfer blanks to the milling machines where they are 5-axis precision milled. Robotic automation with in-machine inspection ensure consistent results. Argen guarantees the quality and fit of our abutments and offers an extensive warranty for peace of mind.
So embracing efficiency, designing good split files. Designing an abutment and a crown at the same time is an excellent way to reduce your turnaround times. Argen offers split file technology, which allows us to manufacture the model, the abutment, and the restoration simultaneously. Our design center technicians design any fixed restoration and specialize in split files. Dominic Leone is our master abutment designer and has designed hundreds of no-touch split file cases. He will teach you the settings, the tricks, and complications you will need to be aware of to ensure your split file designs are successful every time. After the webinar, we will go back and we will have time for a live Q&A, in which case you can ask me any question about split files and the fit and what you can do for each specific case.
Hello and welcome to Embracing Efficiency, Designing Good Split Files. My name is Dominic Leone. I am currently the Technical Support Associate for the Argen Design Team and was previously their Senior CAD Designer. I have an extensive background in CAD/CAM design and will be sharing some of the key factors that come into play when designing and manufacturing split files. Today we will be going over order creation for split files. We will be doing a live design of an anterior and a posterior unit, followed by a recap with the general overview, and then details specific to posterior abutments, anterior abutments, and die spacer settings. So getting started with split file design. The first thing we're going to do is go ahead and verify that our order form is set up properly, and we have all of our material selections and tooth numbers properly selected. So here we see we have two units we're going to go ahead and design today, anterior unit and a posterior unit. Let's make sure that these units are set to the proper materials. We can see that we have a titanium abutment set here and an Argen ZST multi-layer pre-shaded zirconia crown going on top of it. These are going to be true split files. We will be designing them at the exact same time and sending them to manufacturer together. So once we're happy that everything in our order form appears to be correct, we're good to go ahead and start designing. A lot of people ask, why do split files instead of designing abutments first and crowns later? The biggest important is going to be for time saving. By allowing us to design both of these units at the same time, you're going to save yourself an immense amount of time and get your cases pushed forward faster. Okay, let's go ahead and start designing. First step is we're just going to go ahead and place our occlusal plane here. We're just going to make sure that this is properly aligned. This way, every time we proceed to a next step, it doesn't throw us all out of whack. We're not going to go ahead and trim anything off of these scans. They're sufficient for what we're going to be doing today. Okay, first important step is annotations. These blinking dots are asking us to identify the buccal side of each of these restorations. It's very important to make sure that these annotation nodes are placed to the buccal surface for each restoration. If we don't locate these in the buccal side, it's going to cause our abutment blank and our crowns to come in rotated and all out of whack. So once you have those placed, we can go ahead and proceed. Now it's going to ask us to identify the insertion direction. This is all based off of the scan flags and the actual implant itself. We're not going to be adjusting these at all. I do not recommend adjusting them. Next, we're going to be doing some preliminary placement of our crown restorations. Today I'm going to be focusing mostly on the fit and settings for these abutments and crowns, not as much the aesthetics. So we're just going to go ahead and do a basic placement of these crowns. Once we have these placed, we'll go ahead and start proceeding with the abutment design. Okay. 3Shape will generally load you a recommendation for what it thinks the abutment should look like in some circumstances. For anterior units, I'm a big fan of using this custom abutment under the settings type. These provide, in my opinion, a more slim profile, something more natural looking for these anterior crowns. We're going to go ahead and design this abutment to just be 1 millimeter subgingival, nothing too crazy, gentle pressure on the sulcus, and then focus on the angulation to make sure that this incisal edge is pointed in the proper direction. Okay. I also like to look down on these crowns and try and remove some of this cylindrical shape. We want to make sure that this crown doesn't rotate over time or come loose. One of the ways to do that is to build in mechanical retention by giving large flat surfaces and unique shapes. I like to come over here to the margin slider and tune this up to a little bit, make it a little more triangular. This provides us with a little bit more of a natural tooth root shape. It'll make it easier for the technician to finish down the crown and make this look like a natural tooth. At this point, I'm pretty happy with this anterior unit. We're going to focus on the posterior now. So for posterior units, I'm a big fan of, once again, changing the settings type to robotic and start with a full reset. This gives me a nice blank slate for this abutment. I'm going to go ahead and rotate it a little bit to make sure that the mesial and distal are in line with the rest of my teeth here. And we're going to do the same thing. We're going to go ahead and do 1 millimeter subgingival all the way around. So we'll do a millimeter there, 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 and there. It's also important at this point to make sure that we angle the abutment buccal lingually to be in the proper orientation. We want to make sure that our buccal cusp is pointed outside of the opposing teeth, and we'll provide a small little bit of lingual cusp support. Looking at it from the buccal view here, we also want to make sure that we have proper support going to the mesial and distal. So we're going to go ahead and pull up these large nodes here just a little bit and make sure that we have adequate support. Now at this point, our abutment is very circular and very oval, if you will. We want to, again, build in some mechanical retention to it. And by doing that, I like to go over here to the shape tool and then just come on over to the square and give it about a 50% square shape. This will, again, provide us a lot of mechanical retention and just help ensure that our crown doesn't rotate on this abutment. So at this point, we start to get into some fine-tuning for our abutment here. The draft angle box that's located here under this advanced settings tool is defaulted to 3 degrees. In our testing, we found that a 4 to 5 degree taper is about ideal. So by clicking in this and then rolling with your mouse or using the up-down arrows, we can adjust this taper. And this adjusts the overall taper between our side walls that we see here. Now, abutment shoulder length is something that we've also found to be very important. This shoulder right here says right here it's about 0.8 millimeters. We have found that between 0.3 and 0.8 millimeters will provide you with a sufficient shoulder as well as a sufficient room for the extra cement gap spacer and the cement gap spacer to blend and give us a clean bonding area to the abutment itself. A couple other things we're going to go ahead and adjust under the advanced settings here is going to be shoulder radius and top fillet radius. The shoulder radius, as you'll see, is going to increase this shoulder right here. And once again, this is where our cement gap settings and our extra cement gap settings are going to be blending. So having this to be a large, nice radius will be very beneficial. We're also going to increase this top cap radius right here. We're going to increase this from 0.3 to 0.5. This is going to soften the radius that follows along the top profile of the abutment. This will be imperative when we're milling the interior of the crown. Having a larger radius here will make it easier for a burr to get inside the crown and properly mill out all of that area. We don't want to see any hang-ups with our crown seating on this area or down in this area. It's also very important to make sure that we don't add too much pre-anatomy to these buccal and lingual cusps. If we have too much definition going on up here, it's going to be extremely difficult to mill that on the interior surface of our crowns. At this point, we could add a couple other details. We could add on some mechanical retention grooves to this. We can do a vertical retention groove. The best way that I have found to do that is to go into the sculpt tool with the tweezer on the smallest setting that you can. Look down on the abutment so you can see we highlight the black profile, hold the control button, and pull in. This will give us a nice, smooth, clean retention line. I know a lot of people like to subtract objects from the abutment itself to try and give them mechanical grooves, but this we have found is the easiest for milling, both for the abutment and for the crown. I know some doctors are fancy and particular to getting their mechanical retention grooves.
Sorry about that, guys. I don't know what happened there. Bear with me.
Brown. I know some doctors are fancy and particular to getting their mechanical retention grooves. This will mill very cleanly and look very nice when it's done. Okay, let's go back over to the anterior unit for some additional touches and details here. Back under the parametric stage, we're going to go ahead and adjust the taper of this abutment. It's a little bit different for the settings than it is with the robotic abutment. What we can do here is we can, with our wheel on the mouse, click this big center dot so we see these orange lines. Now when we roll our wheel, we can see that we can increase or decrease the amount of taper on this abutment. I go about 5 to 8 wheel rolls, and we have now a nice drafted abutment. It's much more passive for fit. You can see around the walls, and it should be much easier to fit. We're also going to go ahead and adjust the abutment chamfer. This abutment chamfer right here is referencing where these two surfaces meet. Right now it's set to 0.9. We're going to go ahead and set it to 0.5. This is going to give us a little bit shorter of a shoulder, and this will help blend these two together. Once again, we can also go ahead and do a mechanical retention groove on this if we wanted. I know some labs prefer getting one on the buccal side of things so they can help identify what it is. Same thing, we're going to go tweezer tool as small as possible, hold control, and we're going to go ahead and pull that in. And what that does is when we highlight that black profile, it will do it all the way down the abutment. So we can see we have a beautiful, nice retention groove on here now. Okay, now that we're done with most of our initial designing for the abutments, we're going to go ahead and get into the die interface and start changing some cement gap settings. So just to review, cement gap settings are the distance between the abutment and the crown. We have here the cement gap, which is going to be specifically for the shoulder region of this abutment and the distance to the crown. The extra cement gap is in reference to the side walls and the top cap geometry of the abutment and distance to crown. And then distance to margin line, which is in reference for where do those two numbers blend and how far from the margin does that happen. We have found that we are very successful with these split files fitting and seating properly by changing the cement gap to 0.02 millimeters, the extra cement gap to 0.06 millimeters, and the distance to margin line to 0.5 millimeters. If we hit the preview button, we can see a visual representation of what these numbers will actually look like. If we rotate around this abutment, we can see that we have a nice blending area on the flat shoulder of this abutment. And this is what we want to see. In the past, we have found that this number, when set too high, will cause this blending to be up onto the sidewall of the abutment and cause us fit issues. It will be much too tight to get a passive fit. Okay, now let's go ahead and look at the posterior. The posterior follows the same methodology as the anterior units, but we have found that the numbers vary slightly. So once again, under the die interface step here, we're going to go ahead and change our cement gap to 0.01 millimeters and our distance to margin line to 0.30 millimeters. Here is an excellent representation of what I was mentioning on the last unit. We can very clearly see where these two numbers blend together and there's no obstructions of the abutment. They're out onto the shoulder, away from the radius, and away from the walls of the abutment. Now we can go ahead and proceed, move forward. It's going to bring our crowns back in. We will go ahead and attach them to the margin lines. From here you could do any other final adjustments you need to do for smoothing, contacts, minimum thicknesses. And then we could go ahead and send to production. These are some material violations for thickness. For the purpose of this demo, I'm just going to go ahead and click OK to proceed past them. Okay, let's go ahead and recap some of the important topics we touched on today. At the end of the day, we know that successful split file milling is going to come down to a few key factors. The first one being proper abutment design, the second being accurate milling, and the third is going to be sufficient settings for cement gap and extra cement gap. We know that poor abutment design is going to decrease the likelihood of having a successful milling and successful seating. Proper abutment taper is going to have a big impact on the success of our design. We're going to go into that. We know that too much taper is going to allow crowns to rotate and just fit very loosely. And too little taper is going to cause issues when trying to seat the crown. We want to minimize the need for retention grooves by designing retentive shapes, such as triangular margin shapes for anterior abutments and square abutment profiles for posterior units like molars. And we always want to adjust the die spacer settings for these split file cases. The default settings that come with these materials are great for the stone models and working for intraoral cases, but anytime we're going to be doing split files like this, we definitely want to make adjustments to these settings. Let's recap on some posterior abutments. I prefer using the under the settings tool, the drop down to change the type to robotic. It gives me, I feel, a much cleaner slate and an easier approach to doing these posterior units. We want to make sure that we have the taper to about 5 degrees. We want to change the abutment shoulder length to be between 0.3 millimeters and 0.8 millimeters. The shoulder angle should be approximately 15 degrees. We want to try and avoid hard 90-degree angles. We've seen some fit issues when we try and do a hard shoulder. And we want to soften up the radiuses that are going to be used on these abutments. So the shoulder radius and the top fillet radius being increased to 0.9 millimeters and the top fillet to 0.5 would make these larger radiuses than the stock and make them a little bit softer. This will make it easier for milling of the abutment itself. You can use a larger burr to mill it. It will also make it easier to mill the intaglio surface of the crown. Once again, just not as tight defined radiuses just means that we can use a bigger tool and just make it easier to get in there and mill it. We want to make sure that the occlusal surface of the abutment has very minimal definition to it, because once again, anything that's on there has to be incorporated into the intaglio surface of the crown. So the less definition, the easier the milling. Just a simple buccal cusp and a simple lingual cusp to provide support for the zirconia should be sufficient. And then retention grooves are optional. We talked about being able to take the tweezer tool, looking down on the profile, and being able to make a nice, smooth vertical retention groove. I know some designers are partial to subtracting things like cylinders from the walls of the abutment, but in my opinion, this leaves a very sharp line on the abutment, which you're then going to have to mill in both the abutment and the crown. We've seen that using the tweezer tool to make those very smooth looking vertical retention grooves has the highest success rate for milling for both the abutment and the crown. Okay, recapping the anterior abutments. Once again, under the settings tool for type, I like to pick the drop down that works for custom. This custom abutment I feel leaves me with a more natural looking prep type. It makes it more slim and just closer to a natural anterior prep tooth. We want to make sure that we taper the abutment to about 5 degrees. This is a little bit different than when you're tapering with the robotic abutments. With this one, you can either use the large purple node on top of the abutment itself, or you can hover over the blue abutment nodes onto the mesial and distal sides of the abutment, and then use your mouse wheel to roll it in 5 to 8 clicks per side. The abutment chamfer, we'd like to set to about 0.5 millimeters, and this is going to adjust the length of your shoulder. And then we want to make sure that the abutment shoulder and margin design are very smooth and conforming. As you can see on the left side of the image, we have kind of a roller coaster looking margin going on over here. And that's going to be very difficult to go ahead and mill and hope that we get a perfect match with the crown. So by removing any of these different shapes and different heights in the margin, we're going to be more likely to get a successful fit. So you can see the right side of the margin on this image has been evened out and been much smoother. This should make it extremely easy to seat a crown over and match the margin line. We also want to try and do some things, like I said, to incorporate some natural retention. The abutment shape on this one, I like to grab the slider for the margin shape and slide it towards the triangular side. I feel this will give it a little bit more of a natural look. When it's completed with the crown over it, it should look a little bit more natural shape at the root and at the gingival surface. And again, you can always do a vertical retention groove on one of these as well. You can do it on the buccal, lingual, or anywhere that you have sufficient thickness. Let's go ahead and recap on the cement gap. So just to recap here, the cement gap is going to be the yellow imagery showed here. The extra cement gap is going to be the orange and red shown here. So we have found that for the posterior units, we reduce the cement gap down to 0.01 millimeters and the anterior down to 0.02 millimeters. We change the extra cement gap to 0.6 millimeters and then adjust the distance to margin line between 0.3 and 0.5 millimeters. This setting is one of the most important to pay attention to. Your distance to margin line setting should always be equal to or lower than your shoulder length. The image on the left here is a representation of when your distance to margin line setting is higher than your shoulder length. And what we're looking at here is we're seeing where it's blending these two settings. If that number is too high, it's going to try and blend them onto the sidewall of the abutment, which is going to cause fit issues. It's going to be too tight in this area for us to get the crown all the way seated. It's going to hang up in that area and you're going to be having to grind off the inside surface of the crown to make this fit. The image on the right, you can see where the yellow and the orange merge properly on the shoulder of the abutment, which is exactly what we want to see. By adjusting these settings in the die interface step, you can always hit the preview button and watch and see how these two affect placement on your abutment. And once again, this is very important to go ahead and adjust these on every single unit that you're doing for a split file. Whether there's one abutment and a single crown, or multiple abutments under a framework or bridge, you need to make sure that these die spacer settings are changed for every abutment in the bridge or framework. It's very important. And again, all of these are literally showing you what the antaglio surface of the crown is going to look like when it's milled. It's just showing you as a spacer off of the abutment itself. So with these settings, you should be able to achieve proper fitting split files almost every time. We have seen an extremely high success rate with these numbers for these materials. And I highly urge anybody to go ahead and use these settings, as well as try and play with them. Your designs for abutments might be slightly different from ours, or the way that I go ahead and design abutments. But following these ideals and these numbers should definitely land you in a very high success rate for fit and success. Now let's go ahead and change dentistry together. I think that having these tricks and tools in your tool belt will definitely help you down the road, and making sure that the first time you mill this, it fits just like you want it to. I thank you for enjoying me today and hanging out with me. Please feel free to reach out to us with any questions you may have. Thank you.
Okay. Does anyone have any questions? We have a Q&A section on Zoom. If you guys would like to, feel free to type in some questions. I'm open for anything. See, let's go to chat here. Can we watch this again? Is that possible? I believe 3Shape might send out a recorded version of this. Yes, they will. So there will be a recorded version that'll go out, and you guys will be able to go through that again as well. Next question is, what about if we need to design a screw montable crown? Would the settings be the same? Yes, the settings are completely the same. The only difference is, of course, you're putting a screw access hole in there manually. The very important thing is that you're just making sure that your margin width on your abutment design is, equivalent to the actual cement spacer that you're putting there, or the distance to margin line that you're filling out. Does this apply to zirconia with a tie base? With a zirconia abutment. So the zirconia abutments are a little bit different because of the way that those restorations are milled out, and they're nested in the zirconia puck. So the settings are a little different there, and there are some difficulties with that. This is more so specific to titanium abutments and zirconia crowns. Titanium custom abutments, I should say. Yes, we can place a screw access hole. Yes. Yeah, from that would just be a separate thing that you would essentially just request, hey, please add a screw access hole. Yep, no problem. zero risk scan box program. How do I ask for retention grooves? Cement gap alteration. So whenever we're doing a split file case specifically, we automatically build it in. As far as retention grooves and stuff like that, that would have to be in the comment section. We are looking at expanding that part and those selections in the future, in which case we will be able to have specific selections for that instead of having you just type it down in the comment section. So it's the same theory as far as with regular crowns as well. You can typically there's not that big of a difference because you're actually scanning the physical part, right? If you use the original default settings on a titanium abutment, if you were scanning that titanium abutment, you would have no problem with fit. The difficulty is that you're doing it on two different manufacturing. You're doing two different systems, two different mills, two different product lines. And so if you don't change the settings to be this way, then you run into problems. So as far as, I'm sure you'd be able to get away with it with over regular crowns over just a natural prep. But this is really specific to if you're doing, a crown design over a titanium abutment at the same time. What size burr is used for the anatomy of the crown? Honestly, Gabriel, I am not sure on that. I don't know off the top of my head. I can definitely get you that answer though. So Daniel had an interesting question. If he wants to design an all-on-4 case and wants to make individual crowns on a framework, how do I set up the split file? So Daniel, just so I'm being clear on that, you're saying you want to do custom titanium abutments and then you want to put individual crowns over top, correct? Yes. So you would just set it up, typical like your normal case. You wouldn't have to do anything crazy with it. The only thing is you want to make sure that you can ensure that you have proper insertion direction on all those implants. So if you're unable to do something like that, if you don't have a clear path of insertion and you know that draw is going to be an issue there, then in that case, you would have to do a Argen AS 2 connect case to do non-engaging abutments to make sure that it's seat. Otherwise, if you were going to do a split file, you would just do individual abutments, and then you would just put a bridge or single units or whatever you want to do over top. Gabriel asked, do I know when multi-layer HT will be available, HT plus multi-layer? It is currently in beta, and we are going through beta testing on that, and I don't have an exact date on that just yet. Any other questions on this? Okay, I think we're all good. I hope everyone has a good day. Enjoy the rest of the presentations. Again, 3Shape will be sending this out as a recorded version. So if you guys want to go back and watch it and just kind of refresh your skills, feel free. We also have a couple documents that we're going to be sending out to you guys. One will cover the specifics of these settings so that you can always, keep it by your computer and go back and refer to it when you need to. And then we also are going to be sending out the Argen AS catalog that'll show you all the different types of implant systems that we work with, as well as some other selections. And I think that'll be all. So everyone have a good day. I appreciate you attending and take care.